Alrighty, hi everybody, and welcome to Thermochemistry Notes Part 2. So today we are going to be talking about heat and changes of state. All right, so heat or energy is needed to change the state of something, whether we're talking about melting something, solid to liquid, or vaporizing something, liquid to vapor. All right, energy is needed to do that. What's interesting about it is the type of energy. If you ask yourself, what is the freezing point of water? Well, it's 0 degrees Celsius. Well, what's the melting point of ice? Well, it's 0 degrees Celsius. But when ice is melting, clearly something is changing. And that something is still energy. It's just not energy that we can measure with a thermometer. So let's do a little review. When temperature changes, that's a change in the kinetic energy, the energy of motion. All right, and that is what a thermometer can measure. When state changes, it's not a change in kinetic energy, it's a change in potential energy. And that's something that we can't really measure with a thermometer. All right, so what that means is, we're going to scroll down in your notes, we need a couple more constants to talk about, some more numbers that give us information about energy. All right, we have what's known as the enthalpy of fusion, and this is delta H fuse. Delta meaning change in, H is for your energy, and fuse is for fusion. That's the heat needed to melt 1 gram of a specific substance at its melting point. Every substance has its own enthalpy of fusion. The one we're going to be using the most is water's, and water's is 334 joules per gram. Enthalpy of vaporization is the amount of heat needed to vaporize 1 gram of a substance at its boiling point. Water's enthalpy of vaporization is 2,260. You can see that's a big jump. It takes a lot of energy to vaporize water, and that's because of those strong hydrogen bonds that are in water. We're also going to be dealing with water in its ice state and in its vapor state, which means its specific heat changes. If you recall from our first notes, specific heat is the amount of energy it takes to raise 1 gram of something 1 degree Celsius. And for liquid water, that was 4.18. All right. But for ice, it's 2.06. And for water vapor, it's 1.7. So you really just need to make sure that you're using the correct constant when doing your different equations. All right. When talking about this, we often use what is known as a heating and cooling curve. All right. And that's what this graph is right here. This is a heating and cooling curve. All right. On our heating and cooling curve, we have temperature on our y-axis. All right, and then just the amount of energy on our x-axis. So let's take a look to see what's happening. Down here, and I know the numbers aren't written in, but we would assume if we're talking about for water that this would be right here at 0 degrees. And certainly water can be below 0 degrees. It would be an ice cube. All right, my temperature is going to raise until I get to that melting point. I'm then going to melt. So you see this plateau. Anytime you have a plateau on one of these graphs, it means that you have a change in state instead of a change in temperature. All right. So that energy is going to change until it's all melted. I'm then going to raise that temperature again until up here, this is my boiling point, and this is going to be vaporization. And then certainly you can get gases to be above their boiling point temperature. So let's go ahead and we're going to take a look at a sample problem, and I'm actually going to move you right over here so I can write on my paper. Here is our example question. Right. So I have how much energy is needed to raise the temperature of 50 grams of ice at negative 14 to water vapor at 125. I always think it's a really good idea to draw one of the graphs. All right. And mine won't be so pretty because I'm looking through the camera, but to draw one of the graphs to try and figure out how many steps you're going to have in your problem. So what temperature am I starting out? I'm starting out at negative 14. Okay. And so I'm just going to look over here for a second. So here's negative 14. This is water. So I know that 0 is going to be important because that's the freezing point. Oh, let's make this a little higher. And I know 100 is going to be important because that's the boiling point. And then I'm going to end at 125. So that's going to end up being in here as well. So I have ice at negative 14 and I'm going to add energy to it. Well, the first thing that that ice is going to do is it's going to melt. I'm sorry, the first thing it's going to do is not melt. It's going to heat up. It's going to change temperature until I get to 0. All right, well, that's the first problem I'm going to have to do, that first calculation. Once I'm at 0, that ice is going to melt. That's a separate calculation. Then I have liquid water, and that's going to raise temperature until I get to 100. That's the third calculation. I'm then going to vaporize, right? And that's the fourth calculation. And then finally, I'm not stopping there at 100. I told you I'm going to 125, so I'm going to change temperature again. So that's going to be a 5-part problem. All right. Now for our sample, I'm taking you through all 5 parts, going from an ice below its freezing point to vapor above its boiling point. But realize in your practice problems, you could be starting anywhere along this curve, and it will just make it a shorter problem. Okay. So let's go on ahead and back to the computer so we can see how I did this problem. Okay. So scrolling. It's not scrolling. Let me get my mouse going here. All right. Scroll for me. Why aren't you scrolling? There we go. Okay. So just a little reminder, when you're changing temperature, you're going to use a specific heat problem, just like we've always done. However, when you're changing state, you're just going to use an enthalpy problem where all you do is take the mass of your sample and multiply it by one of those constants. Fusion if you're melting or freezing, and vaporization if you're vaporizing or condensing. All right, I'm going to let you go on ahead. If you'd like to try the problem on your own now, that would be great. You can pause the video. Otherwise, you can go on ahead and take a look at what I did. So number 1, all right, I am going to raise the temperature of that ice using the specific heat, and you end up getting 1442. Please don't worry about your rounding with these. You want to just make sure you're getting the idea. The second step, I'm going to melt the ice. And in this case, you notice there's no temperature involved because temperature is not involved with changes of state. Third step is I'm raising. All right. And where did I get that 100 from? Well, I'm going from the freezing point of water to the boiling point of water, and that's 100 degrees. We do expect you to know that. If we asked you any other substance other than water, we would certainly give you the freezing and the boiling point. I'm then going to vaporize that water. All right. And I get that amount of energy. Finally, I'm going to raise that temperature because I remember I said I ended at 125. So that's where I got the 25 from, right? 25 comes from 125 minus 100, which gives you the change in temp. Finally, you're going to add up all of those energies and you should get about 154,000. Again, don't worry so much about your rounding. All right, great. All right, so that ends our notes for day 2. Please go on ahead and give the practice a try. They have some fun problems for you, and have a great day. Email with questions.